Somewhere inside you, there is a scar you didn't know about. Not on your skin, in your DNA. Every human alive today carries less genetic variation than a single troop of chimpanzees. Less. And for decades, scientists believed they knew exactly why. 74,000 years ago, on the island of Sumatra, a mountain did something no mountain has done since. It didn't erupt. It detonated. The blast was so large that geologists still call it a supereruption, a category reserved for events that happen maybe once every few 100,000 years. Ash fell as far away as East Africa, 6,000 kilometers from the crater. The sky didn't just darken. It stayed dark. Try to imagine that morning. You wake up, and the sun is a smear behind grey cloud. It stays that way for days, then weeks. Somewhere, a child asks when the sun is coming back, and no one has an answer. The eruption ejected an estimated 2,800 cubic kilometers of material. To put that number somewhere you can hold it, that's roughly enough rock and ash to bury an area the size of France under a meter of debris. The crater it left behind, Lake Toba, is still there today. It's the largest volcanic lake on Earth, over 100 kilometers long, and people build houses on its shores without a second thought, because 74,000 years is long enough for even a wound like that to look like scenery. This is the world your ancestors woke up into, and for a long time, researchers thought it nearly ended them. In 1998, anthropologist Stanley Ambrose proposed something that would shape how an entire generation understood human history. He argued that the Toba eruption triggered a volcanic winter lasting 6 to 10 years, collapsing food chains across 3 continents. Ash and sulfur dioxide would have blocked sunlight, dropped global temperatures by several degrees, and starved out the plants and animals that early humans depended on to survive. The evidence, Ambrose said, was written into your genes. Modern human DNA shows a strange signature, a population crash. A moment when the number of breeding humans on the entire planet may have dropped below 10,000 people. Not 10,000 in one region. 10,000 total. Fewer people than fit inside a modern football stadium, and from that thin thread, every person alive today descended. It became one of the most quoted numbers in anthropology. You may have heard some version of it. Humanity, on the edge of extinction, saved by nothing more than luck and grit. But here's where the story gets interesting, because the ground itself was about to argue back. Ash from a supereruption doesn't just vanish. It settles into layers, sometimes centimeters thick, sealed into the earth like a timestamp no one can fake. If Toba really emptied the planet of people, you would expect a very specific kind of silence in the archaeological record right after that layer. Fewer tools, fewer campsites, a gap. Archaeologist Michael Petraglia went looking for that gap. Instead, he found the opposite. At a site called Toba in northern India, his team uncovered stone tools both beneath and directly above the Toba ash layer, with no meaningful break in between. People were making tools before the eruption. They were making the same kinds of tools after it. Whatever happened in the sky, the people on the ground kept living, kept working, kept surviving, in relatively normal fashion. That single site didn't fit the extinction story. And it wasn't alone. Similar patterns turned up in southern Africa, where researchers found continuous human activity layered right through the ashfall. In parts of Indonesia, close to the volcano itself, communities appear to have carried on much as before. If Toba was a planet-ending event, it seems to have forgotten to tell the people who actually lived through it. Think about how strange that is. The people living closest to the blast, the ones who should have felt it hardest, left behind stone tools that barely register the disruption. Meanwhile, the theory built to explain their disappearance kept circulating in textbooks, documentaries, and university lectures for a generation, largely undisturbed by the fact that the ground kept quietly disagreeing with it. Then came a more direct challenge. In a detailed review published in the Journal of Human Evolution, researcher Chad Yost and his colleagues went back through decades of climate and genetic data connected to Ambrose's original theory. Their conclusion was blunt. The Toba bottleneck, as originally described, likely never happened the way it had been taught for 25 years. The genetic dip in human population may be real, but pinning it entirely on one eruption, on one single afternoon in Sumatra, was probably too simple a story for what actually happened. So which is true? Did your ancestors nearly disappear? Or did they barely notice? The honest answer sits somewhere in between, and that middle ground turns out to be far more revealing than either extreme. Climate models published in 2021 gave a clue why the two pictures could both be partly right. Toba's cooling effect wasn't evenly spread across the globe. Large parts of the northern hemisphere may have cooled by several degrees. Meanwhile, much of the southern hemisphere barely noticed. Some regions saw rainfall drop by nearly half. Others saw almost no change at all. In other words, Toba wasn't one disaster. It was dozens of smaller, wildly uneven disasters, scattered unevenly across a planet that early humans had already begun spreading across, in small, separated groups. If you were living in a group caught inside the worst of the ash cloud and the cooling, your world may genuinely have come close to collapse. If you were living somewhere the smoke barely reached, life might have gone on with barely a disruption. Two groups of the same species, living through the same eruption, experiencing two entirely different realities. Neither group knew the other existed. There was no news, no way to compare notes across a continent, no way to know whether the darkness overhead was a local misfortune or the end of everything everywhere. Each group had to make sense of the sky going strange, using only what they could see from where they stood. That's worth sitting with for a moment, because it means the fear itself, whatever your ancestors felt looking up at that ash-choked sky, was real and justified even in the places where the actual danger turned out to be survivable. Uncertainty doesn't wait for the full data set before it settles into your chest. This is where the story stops being about one volcano and starts being about something closer to home. Because that pattern, uneven disaster, uneven outcome, repeats again and again through human history. The people who survive the worst events are rarely the strongest, or the smartest, or the luckiest in any simple sense. They're often just the ones who happen to be standing somewhere the damage was thinner. Survival, more often than we like to admit, is a matter of geography as much as grit. There's a second layer to this too, one that has less to do with luck and more to do with behavior. The groups who left the clearest evidence of surviving Toba weren't necessarily the ones in the safest places. They were the ones who kept doing the same small, unglamorous things day after day. Making tools, finding food, passing on what worked. No heroics. No single brilliant decision that saved a tribe. Just a stubborn, boring continuity, repeated at a site like Toba for generation after generation, straight through the worst sky anyone alive had ever seen. That's a strange kind of comfort, if you think about it. You probably imagine survival as dramatic, a single defining moment where everything could have gone either way. But the archaeological record suggests something quieter. Most of what got your ancestors through Toba wasn't a moment. It was a habit. Modern disaster researchers see the same pattern play out in far more recent history. After earthquakes, famines, and wars, the communities that recover fastest are rarely the ones with the most resources going in. They're usually the ones with the strongest routines already in place, the tightest webs of people who know exactly what their role is when things fall apart. Toba may be the oldest recorded example of that principle, written not in survey data, but in stone flakes sitting quietly in an Indian trench for 74,000 years. You inherited more from that habit than you might think. The genetic bottleneck, real or partly overstated, still marks something true about your ancestry. At some point, the human population really did shrink to a size small enough that a handful of climate disasters, plural, not singular, could have reshaped who your ancestors even were. Every language you've ever heard, every face that looks nothing like yours, and every face that does. All of it traces back through a population thin enough that losing a few thousand more people might have erased entire branches of what humanity eventually became. Scientists still argue about how much of that thinning belongs to Toba specifically. Some point to other cold periods around the same era, including a series of harsh, glacial phases that hit well before and after the eruption. Some think the bottleneck happened earlier, tied to humans first spreading out of Africa in small founding groups, rather than any single eruption at all. A population that splits into a handful of small, isolated bands will show the same genetic fingerprint as a population that gets suddenly crushed, even if nothing crushed it at all. That's part of why this argument has run for over 2 decades without a clean resolution, and why Yost's review, careful as it was, could dismantle Ambrose's specific mechanism without being able to fully explain what did narrow the human gene pool in its place. The debate isn't settled, and probably won't be soon. What is settled is this. Somewhere on this planet, 74,000 years ago, the sky went dark over people who had no name for volcanoes, no science to explain what was happening, and no way to know if it would ever end. And they kept going anyway. Not because they were exceptional, because going anyway was, and still is, the only thing that has ever worked. So the next time something in your life feels like the sky going dark, it might help to remember that the scar sitting quietly in your DNA isn't proof that your ancestors were fragile. It's proof of the opposite. It's evidence that somewhere on this planet, in the middle of the least survivable stretch your species has ever faced, someone kept making tools, kept finding food, kept living one unremarkable day after another. You are not here because your ancestors were lucky. You are here because, long after the sky cleared and the ash finally settled, they simply didn't stop.